Mathematics in our world. Mathematics helps control nature and occurrences in the world for our ends. So how does mathematics helps control nature and occurrences in the world for our ends? It gives us a way to understand patterns, to quantify relationships, and to predict the future. Math is a powerful tool for global understanding and communication. Also, mathematics reveal hidden patterns that help us understand the world around us. Mathematics has numerous applications in the world, making it indispensable. Math is indeed indispensable, with application ranging from economics, sciences, businesses, engineering, even arts. Mathematics brings order to our lives and prevents chaos. The ability to reason, creativity, abstract or spatial thinking, critical thinking, problem-solving abilities, and even good communications skill are all attributes that mathematics foster. Mathematical language and symbols. Characteristic of mathematical language. The characteristic of mathematical language are precise, concise, and powerful. Precise is able to make very fine distinction or accurate. Concise is able to say things briefly or summary. And powerful is able to express complex thought with relative ease. Expression versus sentence. Expression is name given to object of interest. Example: number, set, function, matrix, and order pair. That is the example of expression in mathematics. Sentence must state a complete thought or what is the correct answer. Example: 1 plus 1 is equals to 2. It's true. 1 plus 1 equals 11. It's false. Convention in the mathematical language. Mathematicians follow convention so that other mathematicians can comprehend what they're writing without having to continuously redefine simple terminology.
Have a nice day. Today, I discuss some lesson in math. The first lesson that I discuss is for basic concept, set, function, relation, binary operations. Problem solving in reasoning. What is problem solving in reasoning? And another lesson that I will discuss today is inductive and deductive reasoning.
Data management. Polya's 4 steps in problem solving. George Polya, known as the father of modern problem solving, did extensive studies and wrote numerous mathematical papers and 3 books about problem solving. Polya created his famous 4-step process for problem solving, which is used all over to aid people in problem solving. Step 1. Understand the problem. Sometimes the problem lies in understanding the problem. If you are unclear as to what needs to be solved, then you are probably going to get the wrong result. In order to show an understanding of the problem, you of course need to read the problem carefully. Sounds simple enough, but some people jump and try to start solving the problem before they have read the whole problem. Once the problem is read, you need to list all the components and data that are involved. This is where you will be assigning your variable. Step 2. Devise a plan. When you devise a plan, you came up with a way to solve the problem. Setting up an equation, drawing a diagram, and making a chart are all ways that you can go about solving your problem. Carry out the plan. This is where you solve the equation you came up with your device, a plan step. Step 4. Look back. You may be familiar with the expression don't look back. In problem solving, it is good to look back, check and interpret. Basically, check to see if you used all your information and that the answer makes sense. If your answers does check out, make sure that you write the final answer with the correct labeling. Problem solving strategies. Common problem solving strategies. Guess, act it out, draw. In think, guess. This stands for two strategies, guess and check and guess and improve. Guess and check is one of the simplest strategy. Anyone can guess an answer if they can also check that the guess fits the condition of the problem. Then they have mastered guess and check. This is a strategy that would certainly work on the problem, but it could take a lot of time and a lot of computation. Guess and improve is slightly more sophisticated than guess and check. The idea is that you use your first incorrect guess to make an improved next guess. You can see it in action in the problem. In relatively straightforward problems like that, it is often fairly easy to see how to improve the last guess. In some problems, though where there are more variables, it may be not clear at first which way to change the guessing. 2. Act it out. We put two strategies together here because they are closely related. These are act it out and use equipment. Use equipment is a strategy related to act it out. Generally speaking, any subject that can be used in some way to represent the situation the children are trying to solve is equipment. This includes children themselves, hence the link between act and out and use equipment. Draw. It is fairly clear that a picture has to be used in the strategy. Draw a picture. But the picture needs not to be too elaborate. It should only contain enough detail to solve the problem. 4. Make a list. Making organized lists and tables are two aspects of working systematically. There are a number of ways of using make a table. These range from tables of numbers to help solve problems to the sort of table with ticks and crosses that are often used in logic problems. Table can also be efficient way of finding number patterns. When an organized list is being used, it should be arranged in such a way that there is some natural order implicit in its construction. For example, shopping lists are generally not organized. 5. Think. In many ways, we are using this strategy category as a catch-all. This is partly because these strategies are not usually used on their own but in a combination with other strategies. Mathematical problems involving patterns. Patterns are defined as a repeated trend or as something that follows a specific rule. We can use patterns to solve math problems in a number of ways. 2 steps that are always involved in using problems using patterns are as follows. Identify patterns that your data seems to take on. Recreational problems using mathematics. Some examples of recreational math could include classic games such as Monopoly and any number of card games requiring addition and subtraction. Recreational math goes beyond those games and into puzzle and brain teasers that require math to solve but are not the typical learn the formula and apply approach. Some of the more well-known topics in recreational mathematics are Rubik's Cube, magic spheres, fractals, logic puzzle, and mathematical chess problems. But this area of mathematics includes the aesthetics and culture of the mathematics, peculiar or amusing stories and coincidences about mathematics, data gathering and organizing data, representing data using graphs and charts, interpreting organized data. As a researcher, you can use the following: surveys, focus groups, interviews, and questionnaires. A survey is a tool that a person can use to have a brief discussion about the specific topic, like favorite ice cream flavor. A focus group is a group of individuals being interviewed or observed on a specific topic, such as discussion on school safety. An interview can be one-on-one or group discussion as well, where the observer is trying to compile information about a specific topic. A questionnaire shares the same characteristics of a survey, focus group, and interview, as it is a list of questions the observer has to compile for the specific topic. These tools are great to use to organize and visually represent data using various charts and graphs. Graphs and charts are visuals that show relationships between data and are intended to display the data in a way that is easy to understand and remember. People often use graphs and charts to demonstrate trends, patterns, and relationships between sets of data. A bar chart is a graph represented by spaced rectangular bars that describe the data points in a set of data. It is usually used to plot discrete and categorical data. The horizontal axis of the chart represents categorical data, while the vertical axis of the chart defines discrete data.
Mean. Mean is the most commonly used measure of central tendency. When we speak of average, we always refer to the mean. Median. Median is the midpoint of the data array. Before finding the value of the data, must be arranged in order, from least to greatest or vice versa. The median will either be a specific value or will fall between the two values. Mode. Mode is the value that occurs most often in the dataset. It is the number or value or observation in a dataset which appears the most number of times. Weighted mean. The weighted mean of the n numbers x1, x2, x3, and so on till the xn with the respective assigned weights w1, w2, w3, and so on, wn is weighted mean is equals to summation of x times w over summation of w, where summation of x times w is the sum of the product formed by multiplying each number by its assigned weight, and summation of w is the sum of all weights. Measures of dispersion. A measure of variability of a set of a data is a number that conveys the idea of spread for the dataset. Range. The range measures the distance between the largest and the smallest values and, as such, give an idea of the spread of the dataset. However, the range does not use the concept of deviation. It is affected by outliers but does not consider all values in the dataset. Thus, it is not very useful measures of variability. Standard deviation. The standard deviation is measure of how spread out numbers are. Its symbols is the Greek letter sigma. Here are the formula to solve for the standard deviation. Variance. The variance for a given data set is the square of the standard deviation of the data. So these are the formula to compute for the variance for population and for the sample. Z-score. A z-score measures the distance between an observation and the mean, measured in units of standard deviation. The formula for z-score is z equals value minus mean over standard deviation. For population are the formula. If the z-score is positive, the positive score is above the mean. If the z-score is 0, the score is the same as the mean. If the z-score is negative, the score is below the mean. Percentiles. The percentiles are the score points which divide a distribution into 100 equal parts. The formula to solve for the percentile is pk is equals to k times n over 100. Quartiles. The quartiles are the score points which divide a distribution into 4 equal parts. Normal probability distribution. Normal probability distribution is a probability distribution of continuous random variables. Many random variables are either normally distributed or at least approximately normally distributed. Examples are height, weights, and examination scores. It is easy for a mathematical statistician to work with the normal curve. A number of hypothesis tests and the regression model are based on the assumption that the underlying data have normal distributions. Properties of a normal curve. The properties of a normal curve are the distribution curve is bell-shaped. The curve is symmetrical about its center. The mean, median, and mode coincide at the center. The tails of the curve flatten out indefinitely along the horizontal axis but never touches. The curve is asymptotic to the baseline. The area under the curve is 1, thus it represents the probability or proportion or the percentage associated with specific sets of measurement values. Linear regression. Linear regression is the simplest and commonly used statistical measure for prediction studies. It is concerned with finding an equation that uses the known values of one or more variables, called the independent or predictor variables, to estimate the unknown value of quantitative variable called the dependent or criterion. It is a prediction when variable y is dependent on the second variable x, based on the regression equation of a given set of data. After a scatter plot constructed and the value of correlation coefficient is deemed to be significant, then an equation of the regression line is determined. The regression line is the data's line to be fit. The closer the points fit the regression line, the higher the absolute value for r, and the closer it will be to 1 or 1 to negative 1. These are the formula for the regression line. Correlation is a statistical method used to determine if there is a relationship between variables and the strength of the relationship. Pearson correlation coefficient. The degree of linear association or relationship between two variables, at least of interval scale, is measured by a correlation coefficient denoted by R. It is sometimes called Pearson correlation coefficient, Pearson product moment correlation coefficient, in honor of its developer. Formula for correlation is given. The formula for the correlation is given where n is the number of pair scores, summation of x is the sum of x scores, summation of x squared is the sum of squared times squared x scores, summation of x and y is equals to the sums of products of paired scores, summation of y is the sum of y scores, and summation of y squared is the sum of squared y scores.